We did a segmentation analysis in England. All of these people believed climate change was occurring, and we asked them what was their ability to act and what was their willingness to act. And we had two groups up here called the positive Greens and the green concerned consumers. All you have to give these guys are information and they'll act. In fact, what was interesting about this segmentation analysis, seven cohorts, none less than 12% and none more than 18%. These guys you give information. These guys are willing to act, but they don't have the ability, so you give them financial incentives. These guys over here, like the honestly disengaged, otherwise I call them they don't really give a shit about climate change, you can only get to those guys with regulation. It's absolutely crucial to do a segmentation analysis, whether it's climate change, understanding how farmers farm, whatever, in order to understand what policy instruments work. Information, financial incentives, and regulation. So we need international policy. It needs to be long-term. It needs to involve all major emitters. It needs to be equitable, and that's the issue, and it needs intermediate targets. We need to expand our clean development mechanisms, bringing in avoided deforestation. We need energy efficiency standards, and we need to do things sectorally and programmatically. But nothing's going to move without the USA. And if you get the USA, we also need India and China in an equitable, balanced, fair manner. Obviously, from an adaptation strategy, there's no simple way of doing it. It has to be risk. It clearly has to be viewed as a risk, adaptive risk management. It must be linked to all other planning processes, sectorally, and from a national economic perspective. There will quite often need to be law enforcement. We need good information. We need education. We need financing. But bottom line in most countries is we need good governance, and we need good governance. What we also have to realise is ecosystems, again, bringing back climate change and biodiversity, are crucially important. In other words, coastal defence. How do you mix a hard measure with a soft measure? If we maintain our mangroves and our coral reefs, they protect us from storm surges. And effectively, sometimes, however, you need a hard seawall. So the key thing, however, is to think through, if we maintain our ecological systems, we need the seawall. Or how do we mix and match the two together? How do we have sustainable management of our wetlands and our floodplains? Again, don't do what the US Corps of Engineers did along the Mississippi, Missouri, and just keep building the walls higher and higher. So when you breach them, you've got an unmitigated disaster, as we saw in 1991 and 1993. How do you mix and match a hard structure with a soft structure? In other words, managing our wetlands and our floodplains. Managing our forests stabilises land slopes. We saw a disaster in Haiti. All the mountainsides, the hillsides have been denuded of forest cover. All you get every time you get rainfall is soil erosion and mudslides. So the basic point here is, first think about, can you use an ecosystem to manage and adapt to climate change, rather than simply thinking of the hard structure immediately. And in climate change, for agriculture, we need water, temperature, pest and salinity resistant crops. We need to address issues such as our soil fertility, and we need to, now this is mitigation, reduce greenhouse gas emissions. But we have to realise there are physical limits, there are behavioural limits, technological limits, and one I should have put on here, financial limits to adaptation. So the best adaptation strategy is clearly mitigation, but then when you can't mitigate any further, because of a lack of political will, then clearly we have to think what are the best ways to adapt. Right, let me miss this out. So what are we doing in the UK? First, we've got to realise, and we're doing a risk assessment in the UK, you can't think of climate singularly, and therefore we've got 3 emission scenarios, low, medium and high. But you also have to realise there's uncertainty in the climate model. So we ran our climate model, which is a very sophisticated one, that had 400 times. We either changed 1 or 2 parameters at a time to see what was the uncertainty in the projection or simulation of the past and projection of the future by changing these 400, making these 400 changes. We compared it to observations from 1960 to 1990, so we weighted every one of the 400 runs. We then said we could have structural problems with our GCM, so we compared it to every other GCM in the world, and we came out at the end with probabilistic projections for low, medium and high scenarios. We did it for every 10 years, from 2020 to 2100, so they're decadal. It's 25 by 25 kilometre grid square, so very high resolution. And so this is medium emissions, and it just happens to be for the decade of the 2080s. Could have given you any other emission scenario, low or high, and I could have given you any other decade. This is our central estimate. It's not the best estimate, it's the central estimate. And so for the UK, you could see central estimate in 28 medium emissions is a 4 to 5 degrees Celsius warming here, north of Scotland only 3 to 4, and southwest England 5 to 6. If we're lucky and the change is not as high, then there's a 10% chance of this. In other words, 1 to 2 and 2 to 3 degrees Celsius. 90% chance it's greater than this. On the other end of the probability distribution at 90%, there's a 10% chance it could be this. And that is 6 to 7 degrees warmer and 8 to 9 degrees warmer, and there 9 to 10 degrees. Well, 10% chance of that, 10% chance of that. So when we're doing a risk assessment in the UK, we're using these probabilistic. We're looking as a function of emission scenario and a function of probability. We had a heat wave in Europe in 2003. This shows actually UK. It was only 2 degrees warmer than normal. 35,000 people died, 40,000 in Europe, 2,000 in England. The thing to note about the 2003 heat wave, it'll be a very, very average year in the 2040s, and it actually will be a cold summer in the 2060s, something to think about. We also looked at precipitation probabilistically. Annually, this is the annual mean, central estimate 10%, 90%, almost no change, plus or minus 10%. But winter will be 10 to 30% wetter, and summer will be somewhere between 10 and 40% drier. If I go, however, to the extremes, winter could be 60 to 70% wetter, and the summer could be up to 80% drier. So when one thinks about an impact analysis, one has to think about the probability distribution on a spatial scale that makes sense. So we're doing a climate change risk assessment. It's in our Climate Change Act. We're fundamentally defining the problem, identifying and characterising the impacts. We're assessing our vulnerability. We're asking what's really urgent, what do we have to work on today and tomorrow and next week, but also how do we assess risk all the way out to 2100, so we're looking over time, and then we're going to report to Parliament and work with the private sector to assess the risks. This just says the same thing, but in a little bit more detail, basically. So you go from defining the problem, identifying the risks, what are the risk metrics, how to assess it, and how do they vary with climate change, how do we scale it with the different projections, how do we incorporate it into other socioeconomic changes, how do we monetize it, but we also do non-monetary valuation, etc. And we come up with our results, a series of maps, timetables, etc. We've been very, very simplistic to start with, which is not the way to go. But we're looking at things like loss of arable farmland, increase in mortality due to things like heat stress mortality. What happens to our railway lines buckling? You only have to have leaves on the line in England and the train stops. And we have a sustainable. And we have to say, depending on the variable we're interested in, the consequence, what's the climate variable? Is it temperature? Is it precipitation? Or is it a combination of the variables? So we've looked to see what theory tells us. We've looked to see what our experience is in the UK. And effectively, we've come up. So this one was just a simple one. Road series deforming as a function of climate, and the key variable there is continuous days over 30 degrees Celsius. This is the most simplistic of all of them, basically. Then what we ask ourselves is, on this one was on river loss, we have effectively asked ourselves is, as a function of spatial scale and changes in river flow, what are the most likely, less likely and unlikely impacts. So we're playing around games on it. There's hundreds of slides on this. Although I just more say the way we're trying to do it here is we're using some start with some very simple variables. Our next step will to be modelling this very, very closely on agricultural productivity, on impacts on biodiversity, but we had to get this out quick for Parliament, so we are using some fairly simple linear relationships. So in conclusion, We need a legally binding equitable agreement to reduce the risk of climate change. There's actually no dichotomy between economic growth and reducing the threat of climate change. And in fact, not addressing climate change, as Nick Stern said, will almost certainly lead to severe economic loss, especially if you use a low discount rate, which he did. There are cost-effective, equitable solutions, but we have to look at climate change and biodiversity loss. We're a little short, unfortunately, in political leadership and moral leadership. And indeed, we need a radical transformation in our policies, practices and technology, and they're not underway. We need the public and private sector to work together, and we need to take a longer-term perspective. And we need advances in science and technology, but in reality, we're not short of knowledge. We're short of action. Thank you.